Hello. Let's see.
Hello.
Okay, should see the desktop and you should be able to hear me now. Does everything seem okay? Okay, let me see, I haven't got the chat window up yet. Darn it. Okay, okay. Seems that most people are in. Okay, so we're going to keep talking about nested for loops today. So we're still talking about this reading assignment from way back here. Okay, we'll talk about it at least for one more day. So we're still talking about that reading assignment. And for next week, there is a new reading assignment to go back. Well, we're going to talk about methods some more. Okay, we've talked about them before, but we're going to talk about it again. They're real important. So we're going to do them real carefully in more detail one more time. So for next week, we'll be talking about methods. So there's three sections: writing methods, method parameters, and method returns. Okay, and that'll take us all of next week and maybe a little bit longer to talk about that. We'll go over methods real well again. Okay, and let's see. Like I said last time, you know, do these homework problems, do these coding bat problems, you know, try them. Make sure try doing those. And if you have questions about them, please ask. They're really good problems to be working on. Okay, they get you to think about the things that we see in all these examples. So they get you to really do programming instead of just read about it. Okay, now I want to look at more examples of for loops. So I forgot to put them on my desktop. Let me get the examples. Okay. Okay, here's a bunch of now let me show you the idea of what we're going to be doing. Remember, we did simple examples of nested for loops the other day. Okay, so here were the examples we did, like this one here. Okay, this one just printed out the variables I and j so that we could see how they work. So real quick, remember what happens when you have a nested for loop is you start with a value of I, then you do this whole for loop in here. So the I stays held fixed, like it starts at I equal 1, and j goes through all its values. Then after j goes through all its values, you go back up here, I gets its next value. Then you go back in here, and j goes through all its values again. And you see that in the output. You see that I was 1, and with I equal 1, you get all those outputs. J goes from 1 to 6 with I equals 1. That was the first loop of this outer loop and all 6 of the inner loops. Okay. Then you go back to the outer loop and increment I, and then you go back into the inner loop and increment J again. So after you've done the inner loop once, you go back, increment the outer loop, then go back in and do the inner loop. Okay, so this just shows you how it kind of works. Yeah, then here is the third trip through the inner loop. I is 3, j goes from 1 to 6. Okay, now a lot of times these examples were based on tables. Okay, so the next example showed us how if you change things a little bit, this becomes like a table. Okay, so if I just simplify it a minute, let me delete all this. Okay, this made a little table. Right now it's just a table of stars. This was how many rows are in the table. This is how many columns are in the table. And this thing ended one row of the table and made you go from one row to the next row. So this for loop, it iterates across one row of the table and then goes to the beginning of the next row and then you go to the outer loop, and then you start the next row. Okay? And we could do lots of different things when we're going across a row. Now notice the table has to be done from top to bottom and from left to right. Okay, because we're printing things out. So we kind of have to go from I equals 1 is going to be the top row of the table. And then this number is going to represent the last row of the table. This is going to represent the first column. And this will represent the last column. And notice that there's no little ln here in the print. Otherwise, if you put an ln there, everything would be on one line. Everything would be on its own line. So this print, not ln, but print lets you go across a line. Okay, and then the ln is here by itself to end the line and go to the beginning. Okay, so now we can make these things a little bit more elaborate. We had some more elaborate versions of this. Okay, like here, instead of printing a star, we printed the number I. So that printed the row number across each row. So I is the row number. And that was printing the row number all across the row. J is the column number. So that would count up 1, 2, 3, 4, 5, 6. Each row would count up from 1 to 6. Okay, so if you visualize these two, now we'll get 3 tables. If we go to end, first one was just a table of 4 rows of 6 columns, and then the second loop printed the row number across each row. The third one printed the column number across each row, column 1, column 2, column 3. So, okay, so we can do little variations, okay? And then then we can even do more variations. Well, remember, this was an important, this isn't changing the for loop, this is changing where we're writing the code. There's these parameters in the code. Like this was 4 rows, 6 columns. Well, if I change this to 7 rows and 3 columns, okay? So I changed one of them. Okay, now one of them is using 7 rows of 3 columns. The other one's still using 4 rows of 6 columns, okay? So they have these parameters, and parameters are things you can change. And whenever you have something that has parameters, you think that maybe it should be a method. Maybe it should be a method that takes parameters. So here I put the for loop inside of a method called nested for loops, and it takes a parameter, how many rows there are, a parameter, how many columns there are, and a parameter, what character to print. Yeah, we could change what character we print in the table. And then I could call it with 6 rows and 4 columns, call it with 4 rows and 6 columns. So just, yeah, this is 6 rows, this is 4 rows, this is 4 columns, this is 6 columns, and then 8 rows and 3 columns. Okay, so it's useful to bundle things into methods to make it more reusable. Okay, so that didn't change the for loop at all. The for loop, I just took the for loop from the previous example. I just took that for loop and moved it inside of a method and said, okay, this should be a parameter with a name, this should be a parameter with a name, and this should be a parameter with a name. Okay, and then so you end up with that. There's the method. There's the loops inside of the method. Okay, then there was one last thing we did. If this is picking a row, okay, if I go back over here, this picks a row, and then this goes across the columns in the row. So another way to think is this picks the row, this goes across the row. Okay, so you think of it, pick a row, which row number you're in, and then move across the row from left to right. Okay, now as we go across the row from left to right, we do the same thing all the time. What if we wanted to change in the middle of the row? Like in the middle of the row, we would change what character we printed. Why can't we just like go halfway across the row and then go the other halfway across the row? That's what this example did. See, inside, once we pick a row, then there's two loops. One loop to do the first part of the row. So this would do the left part of the row, the first part of the row, or the left part of the row, however you want to put it, the first part of the row. And then this loop would do the second part of the row. So we break the row up into two pieces. So J starts at 1 and goes up to I minus 1. So that's the first part of the row. And then we start a new J, but the J still starts at 1. So this counts how many things there are to go up to. So it's a little bit tricky. This one, essentially, this does the first part, this does the second part. Okay, there are in this one, the number of columns is equal to the number of rows. See, I dropped one of the parameters. It used to be number of rows and number of columns. In this one, the number of columns is equal to the number of rows. So it's printing a square, okay? So this would essentially be up to, okay, you're in row number I, and you go from 1 to I minus 1. Now, if you're in row I and go up to column I, you're in the middle of the column. You're in the middle of the row. If you're in row 5 and you go to column 5, yeah, if you're in row 2, you go to column 2. If you're in row 3, you go to column 3. Actually, not in the middle of the row. You're on the diagonal of the square. Yeah, you're in the diagonal of the square. If you think of a square, we're going to, this is kind of something this is really closely related to like doing coordinate geometry in algebra class. Like if I do, oops. If I create a coordinate system, like in algebra class, see, I have a y-axis and an x-axis. I can think of there being a square sitting here. See, there's a square. There's a square. See, so square sits in a coordinate axis. There's a x direction and a y direction. Okay, then you can draw the diagonal. Now, if you think about it as algebra, this is the x-axis down here. Okay, we tend to call it I or J. You know, we use letters like I and J in our programs. But if we think of it as like an algebra problem, if we think of the table is sitting in the plane, then this would usually be called the x-axis. This one would be called the y-axis. Okay. This line is the line with equation. That's where y is equal to x. You go over and up the same amount. You go over x and you go up by the same amount. So the y is equal to the x. That's the diagonal. Okay. That's going to be real important. We're going to think that way here too. When I picks the row and J picks the column, when the row equals the column, when we have I equal to J, we're on the diagonal of the table. Okay, now this is the diagonal going this way. Sometimes we want the diagonal going this way. Okay, so there's different ways of counting these things, but it's the same kind of idea. Oh, you see, one thing that's real different here is row 0 is at the bottom here. Row 0 here is at the top. See, if I equals 1, you're at the top. So this is going from top to bottom. Here the coordinates go from bottom to top. So they're similar, but not quite exactly the same. Oops. Okay. The coordinate systems are not quite the same. You go from left to right, so you're increasing x here. Here, when J increases, you go from left to right. But when I increases, you go from top to bottom. I equals 1 is the top row, then I equals 2 is the row below it. Here, I equals 1 would be down here, I equals 2 goes up, I equals 3 goes up, I equals 4 goes up. So the direction's a little bit different. So here, the diagonal goes this way. In our case, the diagonal Over in this picture, the diagonal goes down and to the right. In this picture here, the diagonal's down and to the right. Here, the diagonal's up and to the right. Okay, but we still think over here this way. I is a row coordinate, j is a column coordinate. So I moves you up and down. That would be like the y coordinate here, moves you up and down. J moves you from left to right. That would be like the x coordinate over here, moves you from left to right. We can write equations over here just like we can write equations over here. For example, if I want this other diagonal over here, I can write an equation for it. Let's see, how do I get to it? If I want that diagonal, I can write a formula for it because it's just y equals mx plus b. It's a line with y-intercept 1 and slope -1, okay? So that red line, if it was an algebra class, and we'll have to do this kind of thing. We'll sometimes need to do these kind of calculations over here with these things. Here, to get that line, I would have the equation y equals the y-intercept is 1, and then the slope is -1, and the line goes like, it goes like that. It's just simply y equals 1 minus x. Or actually, it shouldn't be 1, it should be b, whatever b is. The b, whatever I start up here, the b, whatever the top of the picture is, b minus x, okay? All right, and then as x goes across, I'm going lower and lower. So I can write little formulas over here, and there'll be times when that's what we need to do. We need to think like formulas. So here, see, I have a little formula, okay? I end up with a little formula over here to try to calculate how much more the row I need to draw. Okay, so in this example, I first go from 1 to I minus 1. Now I'm in row I, and I go up to I minus 1, so I'm almost on the diagonal. So I'm in row I, and I go up to, but not quite hitting the diagonal. Then this one's going to start where this one left off. So this one's going to start in the diagonal, but it starts counting back at 1 again. So it started counting up at 1, and it's going to do the rest of the line. Well, how much is there left in the line? That's how many columns there are. Columns equals row, and I've already done this many. See, actually, I did that many there. So essentially, it's kind of, I'm saying I have this many rows to do all together, and I've done this many so far because of this part up here. So that's how much I have left to do. So I start at 1, and I do a little bit more. Then if you run this, you see that it broke every row into 2 pieces. A part with spaces and a part with numbers. A part with spaces and a part with numbers. So it took every row and broke it up into a first part and a second part. And this one's a little bit tricky. So, but that's what we want to do today. We want to do more examples of tables where we break the rows into 2 or more parts. Sometimes we'll break the row into 3 parts. Okay, we'll see in a minute how we can break the row into 3 parts. Okay, so we start with just, well, remember, first this one just didn't even do a table. This one just showed us how the loop variables work. Okay, so the idea here is this is not a table. This is just showing you that the inner loop variables held fixed at 1 while the outer loop variables fixed at 1 while the outer loop variable changes. Okay, then the inner loop variable changes to 2, and then the outer loop variable changes all the way through again. Okay, so that just reminds us how these work. And then we have a real simple table, just a rectangular table of whatever letter we're printing. Yeah, we could replace the letter with numbers, like what row we're in or what column we're in. See, replace the letter with what row we're in this case. Replace the letter with what column we're in this place. And then the harder thing is start breaking the row up into pieces. That's the hard one. Start saying, well, I want to do one thing for the beginning of the row and something else for the rest of the row. So then you have 2 loops. You have 2 loops inside of there. One loop for the first part of the row, and sometimes we'll have a first part of the row, a middle part of the row, and a tail part of the row. We could have 3 pieces to a row if we wanted. And each one of those will be a loop. Now, I think I mentioned the other day, somebody asked, can you have if statements inside for loops? And the answer is yes. And sometimes it's actually better, instead of saying two for loops, one saying, here's the first part of the row, here's the second part of the row, you could have one for loop and an if statement that asks, am I in the first part of the row, or am I in the second part of the row? So you could also do many of these problems with just two for loops, but in an if statement inside of the inner for loop, asking which column are you in? Are you in the first column? Are you in the first part of the columns, or are you in the second part of the columns? Most of the time, we'll do them with more loops, kind of practicing loops, but a lot of them can be changed to if statements. Okay. In fact, let's see. Let's try writing this one a second time. Okay, so we'll call this one version 2. Okay, and what I want to do is change it so that there's a inner for loop just that goes across a row. So I'll go all the way across the row. The number of columns is the same number of rows. So this loop picks a row, and this loop picks a column. Okay. Now inside there, I want to do an if. I want to ask something, print something in that case, else print something in the other case. Okay. The first case is going to print the blanks. So I know what to do in the first case. This case is going to print a blank. The second case is supposed to print what column? Let's see. The second case is going to print J. Okay. All right. Now I have to think about what goes in here that asks, am I in the first case or the second case? And it's related to what was here. Okay. This one went up to J is less than I minus 1. And then this one picked up where it left off. So let's try just saying, well, if J is less than or equal to I minus 1. Let's try that. Let's just try it. Okay. All right. So that's, see, this one did the first half. And then, well, if you're not in the first half, you must be in the second half. So I don't need a logic there. If I'm not in the first part of the line, I'm in the second part. Okay. So now let me delete these guys. Okay. So now I've got an outer for loop and a single inner for loop, but now I'm asking a question inside of the inner for loop. Okay. Now let's go here, and we've got two versions of this guy now. So there's the original one, and there's the version 2 guy. Okay, so we can try them. Okay, see if I made any mistakes in typing. Okay, no typing mistakes. Let's just go to the end. Let's just see what we got. Okay, I'm almost there. Okay, does anybody see what I kind of, I didn't get quite the exact same thing. How are my outputs different?
One of them starts with 1 every time, and the other ends
I
with
didn't
6 every
quite get
time.
the exact same thing. How in words would you put it? What changed in my second version? I want my second version to be just like the first version, but I didn't quite get it. What's changed? What do I need to fix? The shape is correct. See, it's got the right shape. This one's got the exact same shape as that one. What's wrong with this guy?
Each line should start with 1.
See how this one counted, these started always counting with 1. Yeah, it counted up through, it always, when it started the second part of the row, it always started counting at 1, counting at 1, counting at 1, counting at 1. Here, it started, see, it started counting with a number, it started counting, it just printed the column number. So if it was in column 2, it printed out 2. If it was in column 3, it printed out 3. I really wanted to start out at 1. How can I make this guy start out? How can I make these guys start at 1? If I'm in column 3, but I really want a 1 there, what do? I'm in column 4, but I really want a 1 there. I'm in column 5, but I really want a 1 there. What do I need to, the way you do these problems is you just kind of approach them step by step. I need to do what to these numbers? Just real roughly, they'd have to be, what needs to be done to them to get them closer to these numbers?
Subtract.
You could subtract 1 from the very end. Maybe like a decrementing loop.
These start at 1, this starts at 2, this starts at 3. You need to subtract, you need to subtract something from here. Make it smaller. It was starting at, you want it to start at 1, but it was starting at something larger than 1. It was starting with what row number it was in. So why not, now, if I subtract the row number, that's I, maybe that'll work. See, this was the column number, and I wanted to start with the row number. Let me just try that. Subtract off I, see if that fixes it. So that's going to subtract everything from it. Go to the end. Almost. Let me see what I did wrong. How can I get better?
You've now printed the number 0 in front of.
I wanted them to start at 1, and I said, well, I was in the whatever row I was in, I was starting with the column number. Column number was equal to the row number, so I subtracted off the row number. But now I've subtracted off too much. See, I'm starting at 0.
Can you do I plus 1?
I'm starting at 0. So I go back here. What can I do?
Can you do I plus 1?
Oh, I had my speaker turned off. Has people been talking?
Oh, yeah.
Yes.
I had the speaker turned off. Stupid. Yeah, I had the speaker turned off. Somebody should, and I kept looking at the chat. This is the one time where I kept looking at the chat, and then I wasn't hearing anything, and I kept looking at the chat, and nothing was showing up, and I had my speaker turned off. Ah, okay. Yeah, I should have realized at the beginning when I didn't hear any voices. We should always start with a voice. That way I can make sure I have the speaker turned on. Yeah, that's why I always have to, at the beginning, if you hear me, because I'm afraid I have my microphone turned off, but I should listen to hear you, so I make sure I don't have the speaker turned off. Okay, yeah, all right, so so you probably told me the answer. So what was it we need to do now? Okay, so, right now we're at this, so what needs to be fixed now to get it starting at 1?
Can you do I plus 1 on the I?
Yeah, I need to add it. I need to adjust it back a little bit by adding a plus 1. So now I can just say, oh, let me just add a 1 here. Okay, now in a way I'm doing trial and error, which is not such a bad strategy for solving these problems. Sometimes you can sit down and write some equations and do a little bit of algebra. Sometimes you just stare at the problem, think, I need to subtract something. Let me try subtracting something. Oh, I subtracted too much. Let me adjust it. Okay, let's see if this works. So I'm kind of doing a little bit of trial and error to see if I can just get it to be right. Oh, there they go. They're right. Okay. All right. So I got the same output. Okay. So now I've got it with an if statement that says if I'm in the first part of the row, and then otherwise I'm in the second part. Okay, notice it's the same thing here. See, here a for loop did the first part of the row, and a for loop did the second part of the row. Here, the inner for loop does the whole row, but I ask, am I in the first part? So it's a question. Am I in the first part? And if I'm not in the first part, then I'm definitely in the second part. Okay. Sometimes this leads to an easier way to write the program. Sometimes this leads to an easier way to write the program. You can always kind of go back and forth between them. Well, I shouldn't say always. Usually you could do it either with one loop for the first part and one loop for the second part, or an if statement. So you can usually you can do it one way or the other, though sometimes one of them is going to be easier than the other. Okay. We're going to be practicing for loops most of the time, so we're probably going to usually do it this way, with a for loop for the first part and a for loop for the second part. But you can always ask yourself, oh, how could I have done it with an if statement? Okay. All right. Now let's look at more puzzles. Okay. So let me close these. Okay. Now, see here, I've got a folder called patterns and a folder called puzzles. Now, in the folder called puzzles, there's a little picture, and the idea is, can you write code that makes these little pictures? Okay, we've done some of these already. The triangle goes like that, and you count 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, or like here, it's the same shape, but it counts down. See, this one counted up, this one counts down. 5, 4, 3. Okay, this one, the shape here is the same as the shape here. This one counts up starting at notice it keeps a 6 on the right edge, so it counts up to 6. This one keeps a 1 on the right edge and counts down to the 1s. Now, look at this shape over here. So look, this shape here is the same as the shape here, but this one puts the 1s on the diagonal. So then it counts up from 1 on the diagonal. This one counted down to 1 where 1 is on the right edge. Notice the shape is the same, but the numbers are in different places. These are all slightly different little puzzles. Okay, so there's really only 2 shapes. This shape again, that shape again, and there's this shape here, but I put different numbers in different places. And then here's just like a slightly different problem. Okay. You're counting across here from 0 to 6, but you put spaces here, then you go 0, 1, space, 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 6, 0, space, 2, space, 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 6, 0, space, space, 3, that's column 3, 4, 5, 6. So it's just a little trick. It ends up printing something that looks like the letter N. But the idea is that as you go across a row, you put the column number for 0, then a space, then when you get to whatever row number you're in, well, here here I counted the rows starting at 0. Like strings start counting from 0. Here I did an example where I count the row and the column from 0. So column 0, column 1, column 2. Column 0, column 1, column 2, column 3. So when you're in the same row as column, then you print that number there. Okay, that's just a little puzzle. How would you write nested for loops to do that? Okay, so each one of these little puzzles is solved by one of these. We'll look at them in a minute. And then here's another folder with I just call them patterns here. Okay, starts kind of the same. There's a lower triangle and upper triangle. Here, no numbers, just stars. Okay, so the shape without any numbers in it. Okay, but then here it switches to being, it's here. Now each row here is in 3 pieces, actually. If you think about a row, the row's in 3 pieces here. Spaces to the beginning, a number in the middle, dots on the right. Spaces in the beginning, a number in the middle, dots on the right. So each row now, I'm printing a square, but each row has got 3 pieces to it. Same here. And then I can do some other shapes. Like here's a triangle that instead of being a triangle instead of being a right triangle, with a edge here and an edge here, I've got a 45-degree triangle. Okay, so or I can just do a square. How about just a box? Okay, so I want to put something in the first column, something in the last column, and spaces in between, or a box with its diagonal going through it. Okay, and then here's like a checkerboard pattern. This one's a little bit harder. This is can you draw a checkerboard pattern? Okay, so So this represents one square and then another square. So you have here you have a lot of patterns because you have that is essentially like one row, and that row appears again here. But then here is a slightly different kind of row. But this row is made up of 1, 2, 3, 4, 5, 6 sub rows. There's a lot of pattern here. Yeah, it's a checkerboard. It seems like a checkerboard is simple, but you have to see how many different patterns there are here. This pattern appears here and here, and again every other, it's here, 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 and then in between that guy and that guy is this one, which appears again down here. Okay, this is made up of rows where all the rows in here are the same, but they're slightly different than the rows in here. This one goes at star, at star, at star. This one goes star, at star, at star, at. Okay, so this is actually kind of a tricky thing to write code for. Okay, so we can do different shapes and different patterns. The point of these is they're really just puzzles. They're like doing crossword puzzles. The point of them is just to do them. They're practice and thinking. The patterns you use in these puzzles do come up in real programming problems. In the real world, people don't quite often draw checkerboard patterns on a screen like they would here or anything like that. But this kind of way of thinking, nested for loops are ubiquitous. Nested for loops are just everywhere in programming. And just the way you think about how to organize an inner loop inside of an outer loop, these are real good practice problems. They're real good ways of just getting used to doing it. Okay, so let's do some of these. Let's look at some of these first. Okay, so let's just look at, like, I think there's 7 puzzles here, and let's see, I think it was 1, 2, 3, 4, 5, 6, 7. Yeah, there's 7 puzzles. Each one of these pictures, each one of these is one of these files here. Okay, so let's compare this one with this one. So that would be 1 with 3, because they do the same shape, but what they're doing is they're putting the number in a different place. Okay, so start Dr. Java. I'll open these in Dr. Java. See if it. Okay, there's puzzle 1 and puzzle 3. Okay, and the puzzle shows you what picture it wants, so it wants that picture. Now, now all of these are methods, because as it says in this here at the beginning, each one of these patterns really has a size parameter, and here the size is always 6. But I should be able to do that with a pattern that goes like 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9. I should be able to do this with 9 rows instead of 6 rows, or with just 4 rows. So I want these to have a parameter. So each one is written as a method that takes the size as a parameter. Okay. And then down here, the main method calls the puzzle method with different parameters. And I did this one 2 different ways. So I did this one puzzle 1 and puzzle 1a. So I did it 2 slightly different ways. Oh, see, here's the way with 4 loops, 2 for loops. And then here's the way with 1 inner for loop, but an if statement. Okay, so it shows you both ways. You could do it with 2 inner for loops, first half, second half, or 1 inner for loop, ask, am I in the first half or am I in the second half? Okay, so that's called puzzle 1 and puzzle 1a. And if we compile it and run it, there's the output with the parameter being 9. Then if I want, I can change the parameter to make one of them give a make a parameter. Well, let's make them both parameter 4. I have to recompile it, run it again. Okay, now the parameter is 4. So the size of the triangle is 4 rows and 4 columns. Okay. All right. Now what about the other one? Now puzzle 3 differed from puzzle 1, they're the same shape, but puzzle 3 counted up to 6. Puzzle 1 counts up to 6. Puzzle 3 counts down to 1. So this one always has 6 on the right edge. This also has 1 on the right edge. So this one always counts up to 6. This one always counts down to 1. Okay? All right. Now, where would the difference be? The difference would be, okay, if you look at that row there, it starts out with a certain number of spaces. The equivalent row there starts off the same number of spaces. So the first part of the loop is the same in these because it does the spaces. So in puzzle 1 and puzzle 3, the first loop should be the same. It prints the spaces. So that would be this one and this one. They should be the same. Okay, if I switch between them, you see that nothing's changing in the highlighted part. The highlighted part's the same. Okay. Now this is a real useful trick here. Notice how I switching between two programs. I want to compare them. That's a real common thing to want to do. Yeah, notice I can see where the differences are. See how the pattern up here is changing. A lot of times when you're trying to find a bug or if you're trying to understand how a program works, it's worth opening it up and getting the lines lined up and switching between them. It's a really helpful trick. Now notice how you can see that what's changing is down here. That's the second part of the line. You can see when I switch between them that where the changes are happening. Okay, the change is happening. Yeah, as I switch between them, you can see where the change happens. I do this all the time. I do this every day. I open up two files to try to figure out where something's changed, why one thing is different than another. Because you end up with lots of code that's similar, similar pictures, but not quite exactly the same. So when you have similar things, but not exactly the same, a lot of times you want to figure out where was the difference. Okay, the difference was what we printed out here. What are we printing in the last half of a row? Okay, so we print the first part of the row, we go up to not quite the diagonal. Remember, if we're in row I, column I would be the diagonal. We want spaces up to, but not including the diagonal. See how the diagonal's got the number 1, 2, 3, 4, 5, 6, or 6, 5, 4, 3, 2, 1. So the spaces go up to, but not including the diagonal. There's two ways I could write that. Here I wrote it up to and including the number 1 less than the diagonal. Up to and including the number 1 less than the diagonal. I might have found it easier to write that this way. How would I read this now? Before I read it, up to and including the number just before the diagonal. If I write it this way, I think it's easier actually. How do I read this? I is the diagonal because it's also the row. If I'm in the same row and I'm in the same column, I'm on the diagonal. So this would be up to, but what? What's the difference between less than and less than or equal to? Yeah, that would be up to and including. See, that would be up to and including this guy. So if I do it like this, it's up to, but not including the diagonal. So it goes up to, but doesn't quite hit the diagonal. Again, that's the same thing as saying this with a -1 here, because this goes up to and includes the space just before the diagonal. Okay, so now that part's the same in both of these. See, that part's the same in both these examples, because both of them do the same thing in the first part of the line. They both do the same thing in the first part. Now, what really changes is down here. What do you do in the second part of the line? Okay, all right. Here, notice that I'm printing the column number. That's easy. Yeah, counting up to 6 where 6 is on the edge is actually saying, well, I'm in column 4. See, I'm in column 4. I'm in column 4. So that's actually easy. The number I'm printing just is what column I'm in. J is our column counter. I is our row counter. J is our column counter. So we see that we're just printing out the column number. This one's a little bit trickier, okay? Notice that the number here in a column doesn't change. See, there's 3, below it is 3, below it is 3, below it is 3, but that's not column 3. Below it is 2, 2, 2. So I'm putting the same thing in that column, but it's not exactly the column. What is it though? This is column 5, and I'm printing the number 2. This is column, what is it? This is column 3, and I'm printing 3. Okay, but this is column, see, column 1, 2, no, this is column 3, and I'm printing 4. This is column 1, 2, 3. In column 4, I'm printing a 3. Okay, can you see, like in column, sometimes it helps to go to the ends. In column 1, I'm printing 6. In column 6, I'm printing 1. What would give me that? In column 1, I need a little equation. In column 6, I'm printing 1. In column 1, I'm printing, in column 1, I'm printing 6. In column 6, I'm printing 1. So if I start with the column number, what do I do to it to flip it over like that? Okay. See, it's the equation real similar to what we wrote a minute ago. Okay. You want to subtract off from the biggest possible. Like see, size is the last column. That's the 6 here. But I want to subtract off the column number. Like, so when I'm in column 1, I want to subtract off 1, but then I need to add a 1 here so I don't get 0. So I don't start at 0. I don't want to end up at 0. So I make it size plus 1. So if there's 6 columns, I want this to be 7. Then I subtract off what column number I'm actually in. Okay, so that would give me here, that's column 6. 6 plus 1 is 7. Then subtract from 7, 6, I get back to column 1. Okay. Notice I need to come up with a little equation. Sometimes you need to get a little piece of paper. You can either do this by trial and error. You can say, well, the columns numbers go up, 1, 2, 3, 4, 5, 6, but I want to go down. If I want something to go down as not something else increases, I need to subtract it off. When you subtract J from something, the result decreases. Okay, so here I need to decrease. So I need to subtract J from something. Okay, and then you guess at what that something should be. Here it would be size plus 1. Okay, so these two look real similar. Okay, now here's another one with the same shape. So how does it differ? So 1, 3, and 5. Now if I notice here, see, this part here still doesn't change. This part here is not going to change. 1, 3, and 5, they all have the same thing in the first loop. They all have the same thing for the first loop, but they vary on what they do in the second loop. Okay, so they have to work harder on the second half of the line. Okay, so first half of the line is the same. The real work is in the second half of the line. Okay, all right. Now let's look at the third one. Look here. Okay, now this one says do part of the line and then do however many spaces are left over, but start counting at 1. So the idea is that there's size number of columns. That's how many columns there are. You're going to do if you're in row J, you do J minus 1 spaces. So if you're in row J, if you're in row I, I'm sorry, I is the row counter. If you're in row I, you do I minus 1 spaces. Okay, so you do I minus 1 spaces. That leaves a number left over. However many, what's left over is the total number of rows, the total number of columns, which is the number size, minus what you've already done. So what's left over is the total number of columns minus the number of columns you've done. Okay, here's the number of columns we've done. Now notice here, total number of columns minus how many we've done. See how many we've done? Here's how many we've done. So it says it right there. What do I have left to do? I have to do the total number of columns minus what I've done so far, because that's how much I've done so far. But I want to count up from 1 up to that number. This is how many columns I have left to do, but I'm just going to count them starting at 1, 2, 3, 4, 5. So I start my counter at 1, and I count up to however many I have left to do. Okay? And then I print that number that's counting up. Notice that J is no longer J is not the column counter, column number. In this case, J is not the column number. I'm not in column J. Over here, we had I was the row number and J was the column number. Okay, but now and that was true over here. But now J is just something counting up from 1 here. J is going to count up from 1 until I get to the last number I want. Okay, so J starts at 1, and I'm going to count up however many slots I have left. The number of slots I have left is the total number of columns minus what I've done so far. Okay? Now, this is not the only way to do this. If you go home and you try to redo this problem, you might come up with a slightly different set of formulas than I did. Now, you could also do it with an if statement. See, here's the version with an if statement. But you might just change your point of view. Like you might have this formula a little bit differently, and then you have something else here. You could do these a variety of different ways. Like you could have a different set of formulas here, but then put something else in here that makes it still print out this thing here. So not every, what I'm showing you here is a way to think about these. And every time you do one of these, you'll probably think of a slightly different way to do it. But you have to come up a way. You have to think, I need to get this pattern. The real puzzle here is find code that generates that. And think in terms of first part of the row, second part of the row. Do whatever you need to do to get the first part of the row. Then think of a way to get the second part of the row. How you need to know, you have to do a certain number of steps to do the second part of the row. Okay. Now here I did it with counting up from 1. So I made the J count up from 1. See, if I did, let's see, I could do it another way. Let's see. I want to do this one. Let's see. Let's do it let's call this puzzle B. So let's do it a third way. But I want to change here. Okay. Okay. This did the first part of the row. So what's left? Well, what's left is to start at I. See, we stopped at I minus 1. So let's pick up where we left off. But if we pick up where we left off, we're going to go up to size. Now J is the column cut number. Okay? Because see, what I'm going to do is J starts at 1, goes up to I minus 1. That's just before the diagonal. Then in the next loop, I start with J equals I. I'm going to start on the diagonal. And I'm going to go up to the last column. Okay, so for me, maybe that's easier to think about. I did the first part of the row. Now I did the second part of the row. Okay, now what do I print? But now I have to change what I print here. Okay, because I don't want to print the column number. I don't want to print 3, 4, 5, 6 here. I want to print 1, 2, 3, 4. So now I have to adjust what I print here. So I'm going to print J minus something because I need to shift down. See, J is like right, if I'm in this row here, J starts at 0, 1, 2, 3, 4, 5, 6. Yeah. So the J is skipped over the first part, and J starts here. So that J is in what column I'm in. But I want it to shift down to 1. I want this to shift down to 1. Now I could try subtracting I. Okay, that's a guess. Let's just call it, see what we get. Okay, I got that same kind of problem. I subtracted off too much. I wanted to go down, I wanted each row to start with a 1. Now I'm starting them off with a 0. Okay, so I subtracted off too much, so I can fix that by subtracting off I and then add another 1 back to it. Okay. Okay. Yeah. So now some of you might think one of these is way easier. Some people might think this was easier. Some people might think this one's easier. They're both right. They're both completely okay. The idea is whatever way you can think about how to do it. Here I thought first part of the row, pick up where I left off. Okay, so I'm just picking up where I left off. If I pick up where I left off, then I have to adjust what I print. Here I said, okay, I have this much left to do. I've done part of the first row. I have this much left to do. So I'll start counting at 1 up to how much I have to do. And then I just print out J, because J is this thing I want to print out. Some people might think, if you were writing it yourself, you might think of it this way first and go ahead and do it. You might think of it this way first. The real issue is that you have to come up with a way to do it. If somebody gives you a picture like this, you have to translate that picture into some chunk of code. Okay, and then you also may just want to do it as an if statement. Okay, this one actually turns out to be kind of easy. Well, let's look at what you do here. If you turn it into an if statement, sometimes it's easier, sometimes it's a little bit tricky. So here's what I'm going to do. I have a variable that tells me what row I'm in. I'm changing from I and J to row and column. So my outer loop picks what row I'm in. I go from row 1 up to row size. Then I have a column 1 up to column size. Okay, so now that is what row I'm in. That's what column I'm in. And then I want to draw this shaded picture over here. Notice I wrote an inequality. What does column larger, well, what does that equal? If I say column equal row, where am I in the picture?
Diagonal.
On the diagonal. Now remember, that's kind of thinking this way. If column equals row, you're on the diagonal. But we're not doing, remember, but we're flipping this picture over because our Y starts here and goes down. So we're actually on that diagonal. Okay, so if the row is equal to the column, I'm on that diagonal. Okay, now what I had was this, greater than or equal to. The column number is larger than the row number. Where am I in the picture?
The diagonal and to the right of it.
Yeah, what we might call the above the diagonal. We tend to say we're above the diagonal. I'm in this shape. I'm in this part up here. I'm in the part where the diagonal, and see here, the diagonal is 1, 1. I'm 2, 2. I'm in column 2, row 2. Now I'm in column 3, 4, 5, 6. Notice that the column numbers were larger than the row numbers. Right now I'm in row 3, column 3. But then if I move to the right, column's getting larger. So when the column number is greater than the row number, I'm in the right half triangle. So some people think of it as the right half. Some people think of it as the upper triangle, the part that's above the diagonal. Okay, so now where am I here in this? What's the opposite of that one? This one would be where?
Below the diagonal.
Below the diagonal. So that's when I print the spaces. See, so I'm printing. Notice that I'm not doing spaces first. See, since this one's got a different logic to it, I don't actually have to do left to right. I can just say, am I in the upper triangle or am I in the lower triangle? If I'm in the upper triangle, I'm printing a number. If I'm in the lower triangle, I'm printing a space. The spaces come before the numbers, but that's not how I'm doing it. I'm asking a question. Am I in the upper triangle or am I in the lower triangle? And I'm printing only one or the other. So I'm at a certain spot in the square and I'm asking, oh, am I in a spot that's in the upper triangle or am I at a spot that's in the lower triangle? Am I at a spot that's in the upper triangle or am I at a spot that's in the lower triangle? And then I print the appropriate thing. So it's kind of a different way of thinking. And notice I said that sometimes when you write these with if statements, they become easier. Sometimes they become harder. Sometimes what it is that you just change your way of thinking a lot. You know, here I'm changing my way of thinking. I'm thinking, I go through the whole square, and then I ask for each dot in the square. I ask, am I in the upper half triangle or in the lower half triangle? For each dot in the square, I just ask, am I upper or lower? Am I above or below the diagonal? Okay, if I'm below the diagonal, that's easy, print a space. If I'm above the diagonal, that's a little bit tricky. What do I print when I'm right here? Okay, I'm in the second row and the fifth column. I'm in the fifth column, second row, and I want to print a 4. Well, it takes a little bit of work to figure out that that's column minus row plus 1. How can you get that? Well, sometimes by trial and error. You know, just try different. You know, you've got the column number to play with, you got the row number to play with. You know, if you played around, like if you did that, suppose you just said, well, maybe it's column minus row. Then you'd find out that you're off by 1, and you could adjust it to. You know, you could adjust if you run this one. So this one is, I want to print out 5A. So here, I want to switch to A. Okay, like right now, suppose I made that guess. I'm going to print column minus row. So I run it, and I see that I'm off by 1. See, I wanted 1s on the diagonal. I got 0s on the diagonal. So what I'm printing is 1 off. So I can go over here and just say, oh, okay, I can fix that. I can add a 1 to this. Okay. All right, so that's a different way of thinking. Okay, here the way of thinking is pick a point in the square and then ask where that point is. Pick a location in the square and then ask, is it in the lower half or is it in the upper half? Okay, like let me show you, like I could do a little, let me do a little trick here. I've divided the picture up into 3 parts now. What are the 3 parts of the picture? What's this part? I haven't done anything with it yet, but what is that part of the picture?
The diagonal.
The diagonal. What part of the picture is this logic?
Above the diagonal.
Pardon me?
Above the diagonal.
Above the diagonal. Then what's left?
Below it.
Yeah. Okay. So let me do some things. Okay. Let me print dots below the diagonal. Let me print @ signs on the diagonal for the heck of it. I'll print an @ sign on the diagonal. and I'll print these numbers above the diagonal. Okay. Dots below the diagonal, at signs along the diagonal, and these column numbers, well, these decreasing column numbers, yeah. So let me change it. Let me print the column number above the diagonal. Let me just go ahead and just print the column number, okay? Right? Dots below the diagonal, asterisks on the diagonal, and the column number above the diagonal, okay? And I've got, now I can do almost anything I want here. I could print, I'll print a space on the diagonal. I'll print a star below the diagonal, and I'll print a $sign above the diagonal. No, I'm sorry, $sign below the diagonal, stars above the diagonal, and spaces along the diagonal. Okay. And you could do, let me oh, and let me change, let this bigger. Make this one bigger. Okay. Now let me add another piece of logic to it. I added a fourth chunk. What's my fourth piece? Now my picture is divided into 4 pieces. 1, 2, 3, 4. What have I done here? What have I made special in this by asking that? Oh, I'm sorry. Equal. Okay. What did that do?
The first row.
Yeah, it lets me do something special in the first row. Okay. How about in the first row, I print, in the first row, I'll print equal signs. Okay. And actually, I'd like that to be in the bottom row too. I want the first row or the bottom row to be, I want the top row to be equal signs and the bottom row to be equal signs. Okay, so compile. Whoops, what did I do wrong? Oh, I forgot the equal again. See, okay, first row equal signs, bottom row equal signs. I'd like to put a frame around this picture. I want the left edge to be equal signs, and I want the right edge to be equal signs. So I actually want a frame around the picture. Okay, so how can I add to this? Say, what can I do to say, oh, I also want the equal signs to be on the left edge, and I want them to be on the right edge also. Let me see, do a little bit of logic now.
You say if column equals 1 or column equals size.
Yeah, so now I can just keep building this line. If I'm in the first row, or I'm in the last row, or I'm in the first column, or I'm in the last column. Okay, now I've essentially said this is the border. See, I've got a little piece of logic that says, oh, if you're on the border, if you're in the first row, last row, first column, last column, print an equal sign. Okay, so I printed a little border around the picture. And then I have my then the inside of the border is chopped up into 3 pieces, a diagonal, a lower triangle, and an upper triangle. Okay, and we're getting real close to the logic that you use when you write games, and you have to figure out where things are in a grid. We're essentially asking logic that says, where are we in a grid, and we're doing different things depending on where we are in a grid. Okay, so this is real kind of useful logic to do. Now, here's a little funny thing. This one would be real hard to do with nothing but for loops. Yeah, it actually is, in the long run, a little bit better to use logic than it is to use for loops. This one, I probably could do it with for loops. Okay. The first row has to be that. Now, in here, if I did this with a for loop, the for loop would have to have a first part, a second part, a middle, third part, a fourth part, and a fifth part. So I would actually have a very messy set of for loops because there would be something at the beginning, then there'd be a for loop that did those pieces, then there'd be something in the middle, then there'd be a for loop that did those pieces, and then it would end with just an equal. So what I would actually have would be print equal, for loop, print space, for loop, print equal. So I would need a print, for loop, print, for loop, print, if I did this with all with for loops. And that would probably end up being a little uglier than if I do it with one. But here, I'm writing a fairly complicated if statement. I'm saying my picture is divided up into a border. This one does the whole border for me. And then a diagonal. And then what's above the diagonal, then what's below the diagonal. Okay. All right. So I could do things with logic, or I can do things with for loops. Okay. So, and I can create nice little pictures. I can create interesting pictures like this. Okay. Now, let's see. Now, what about, okay, we were comparing 1, 3, and 5 because they all had the same shape. Let's compare 1 with 2 because they have the complementary shape. So let's just do one more. Let's ask what changes 1 to 2 when they have this one is the upper triangle. This one's a lower right triangle. Notice that, see, there's a different diagonal here. We're actually switching from this diagonal to this other diagonal. See, there was a different diagonal involved. So what changes from 1 to 2? Now, okay, now see if you flip back and forth, you kind of see, well, now not only do you have to change both this loop and this loop. Okay. Okay. All right. This one prints spaces. This one also prints spaces. Okay. The first part, see, in both this one and this one, you start with spaces. So you start with spaces there, and you start with spaces there. So 1 started with spaces up to and not including the main diagonal. Spaces up to and not including the diagonal. But this one, the spaces go over to this other diagonal. We haven't tried that diagonal yet. See, this diagonal is where I equals j. Row 1, column 1. Row 2, column 2. Row 3, column 3. Row 4, column 4. Row 5, column 5. Row 6, column 6. That's the easy diagonal. This diagonal is the opposite one. In our picture in algebra class, it's the difference between that diagonal and this diagonal, where this one was the easy one, y equals x. This is the trickier one. It's y equals b minus x. Wherever your b is that corner up there, however high your square is. So this diagonal is the trickier one. Now in this picture, this is the easy diagonal, this is the tricky diagonal, but there you're starting 0 going up. Here in these pictures, row 1 starts here and goes down. So this becomes the easy diagonal, and this is the slightly tricky diagonal. This is the one that needs a little bit more complicated formula. Okay, so the diagonal now looks like this. You back off from the right edge. See? That diagonal is 1 step away from the left edge. That diagonal is 2 steps away from the left edge. That diagonal is 3 steps away from the left edge. This diagonal is 1 step away from the right edge. This diagonal is 1 step away from the right edge. 2 steps away from the right edge. This is 3 steps away. So if you think about the right way to think about it, they're not hard. The diagonal is moving away from the left edge. Here, the diagonal is moving away from the right edge. So I need to move away from the right edge. The right edge is size, and I move I steps away. That takes me to that diagonal. Okay, So with the right little trick, it becomes kind of easier to find that diagonal. You think of, instead of moving from the left edge to the center, I move from the right edge to the center. Okay, so I move from the right edge, left, that's a subtraction, that much to the center. Okay, so that gets me on the diagonal, and I print spaces. So I print from 1 to the diagonal spaces. Okay, now here I pick up where I left off. See, I left off at j equals size minus I. Here I'm going to pick up there. I pick up at size minus I minus 1. If you subtract 1 from, well, actually, I probably should have wrote that better. I take out those parentheses, and it looks like this. Probably a little bit easier to read that way. There. Size minus I plus 1. So I'm picking up where I left off. So I just pick up where I left off, and I go to the end. So I pick up where I left off, and I go to the end. Okay? So with the right way of thinking, you can kind of see where I got these little algebra formulas from. Okay, well, we ran out of time, so let's quit here. There's lots of these examples, and eventually I'll give you homework problems that are similar to these. So I'm eventually going to give you a homework set that's similar to these kinds of problems, and give you little puzzles where you have to figure out for yourself like how to build up these pictures. Okay, there's lots of examples. Like this one's a little bit tricky. You can go look at the example of this one, and they all can be done with nested loops or nested loops with if statements. Multiple inner loops, or one inner loop and an if statement. Sometimes this is easier. Sometimes this is easier. Okay, I'll go ahead and quit because we've run out of time. Study these examples. Coding Bat does not have examples like this. I really wish Coding Bat did these little picture puzzles. Coding Bat does. I think they might be too hard for them to grade. So they don't have. These are very common. You see these in textbooks all the time, but they don't seem to be. Coding Bat didn't put any of them up there. So I'll eventually I'll give you some, but do the Coding Bat. So Coding Bat problems are string problems. The for loop problems in Coding Bat tend to be on strings. Those are a little bit easier for them to grade. So the for loop examples in Coding Bat all tend to be for loop problems involving strings, not these little tables. But do the coding, I gave you some Coding Bat problems. Please try those. They're really good to do. And if you have questions, send me an email. Send email, ask questions by email or ask for a meeting with Zoom. Okay, so I'll go ahead and stop here, and we'll meet again on Monday, and have a nice weekend. And please send me questions if you have them. Okay, bye-bye.